If we talk about the starting of this chapter, the kinematics, so already you know about the concept of distance, displacement, what is the difference between speed and velocity, the uniform velocity, variable velocity, acceleration, uniform acceleration, the motion graph, distance time graph, and the speed time graph, right? So you all know that how to find
Yeah.
out the distance from speed time graph, the area under the curve, and you also know about that how to find out the unknown value, any quantity from the curve of the graph, right? By drawing the gradient that is tangent to the curve, right?
Yep.
Okay. Now, the most important thing is in this chapter that you can say that that is new for you this time in AS, that is related to the equation of motion. Just like if you know about the formula of acceleration is equals to final velocity minus initial divide by time. And if we cross multiply time on the left hand side, so your equation will be like VF minus VI equals to AT. So in this chapter, we know that we have to drive the concepts also. So the very first concept that we start with this chapter is related to driving equation of motions, right? Derivations of equations. So the first topic that we are going to start with is the derivations. And the first thing that we need to drive is to drive final velocity is equals to initial velocity, right? So this is the equation that we want to drive, right? So basically, we want to start with the basic, the derivation of this concept. This is the equation, and you can also drive this equation from the formula of acceleration, right? Because we know that acceleration is equals to final minus initial divide by time. But in this scenario, we need to drive this equation. So let's suppose if we start from the basic, that what is the concept behind this equation or how to drive this equation. So let's suppose if we first consider speed time graph, right? Because we know that the gradient of speed time graph gives you the value of acceleration. So initially, if we consider a graph, so let's suppose if we consider any point on speed time graph, this is the speed, this is time. And let's suppose we are starting with any initial velocity, right? We are not starting from zero. Let's suppose we are starting from any point on initial velocity. So, and body is moving with constant acceleration, right? So constant acceleration means there will be a straight line moving in upward direction. So this line shows you that body is moving with constant acceleration, right?
Yeah, and it also shows that it didn't start from like zero.
Yes. And one more thing you can easily identify that we are having some final velocity also.
Yeah. So you just like read it from the graph.
Yes.
There's no calculations.
Yes. So this is purple line shows you the initial and the yellow point shows you the final speed or the final velocity. And let's suppose if you just mark the projection of the graph on x-axis. So this is the total path that is covered on the x-axis. And we know that we started from initial velocity. So some part on the x-axis is not covered for our case because we started from some initial point. We are not started from zero. So basically whole path is divided into two different shape, right? One is right angle triangle and second one is the rectangle. Okay. So basically we need to start the derivation like this. The change of velocity with respect to time. Okay. And you know that change of velocity is final minus initial divided by time. So this is the reference that we started from. And you also know that v minus u over t is equals to acceleration. So you can just simply write it as acceleration will be equals to final minus initial divided by time. And you just simply multiply time on the other side. Or further, we may write this equation. V is equals to, so this is the very first equation for your, or we can say that this is
Okay, so that's like
equation.
easy.
Yes, this is the easy one because this is the first one, right? The other two might be different from this because the first one is just simply derived from the formula of acceleration, right? And this graph is just for reference because for the other equation, we are also going to use the same graph, right? So that graph is reference for all of your three equation. So basically this equation is first equation of motion. Because if someone asks you to find out the distance from the same figure, so you know that you can easily find out with the reference of area under the curve, right? And in the first equation we are not having any value of distance. So let's suppose if we need to find out the distance, so we also need to drive another equation for the distance. So basically the second equation that you need to drive is related to the distance, and second equation is s equals to initial plus final velocity divided by 2 into time. Okay. So this is the second equation of motion that we need to drive, because we know that from the graph we are easily able to find out the distance also. So let's suppose if we consider the second situation. So in second situation, so we can say that the average velocity,
I can't hear you.
am I not audible?
Now you are.
Okay.
For a second, I couldn't. I think
Okay.
my Wi-Fi switched.
Okay. So basically in second part, we take the reference like this, that the average velocity is halfway in the sense, because let's suppose if you need to find out the average velocity. So let's suppose if we take the average between 1 and 10, so the value average means the mid value or the middle section of whole graph or the whole diagram which we are using, right? So let's suppose if we want to talk about the average velocity, so basically your average velocity will be the halfway of the graph, right, between u and v. Because again we are taking the reference from the graph, so let's suppose if we take the reference, so we are talking about the average value. So your average value will be in the middle like this. Okay. So basically you can easily find out the average value from the graph by marking the line at the halfway between u and v. Okay. Clear?
Yes.
because you know that in your equation there is a concept of average velocity. U plus V divided by 2 is basically the average velocity. So that's why from the graph we take the reference that we need to take the average velocity, and from the graph we take average velocity V plus U divided by 2. Okay, we take the graph as a reference because you know that what is the source and why we are taking the average. So that is the concept, because we need to find out the distance, and for distance we need to take the average value, because in speed time graph we never do like this that we take one point on the graph and just find out the distance, because a distance can be find out with the concept of area under the curve. And the second concept that you need to follow for the second equation is, if we need to find out the displacement or distance, so basically distance or displacement will be equals to average velocity multiplied by time. So we already find out the value. Yes.
No, I'm saying that I get it.
Okay. So now simply just you need to do S for the displacement, and average speed shows you. So this is your second equation, right?
Yep.
And there are multiple ways to write the equation. You may also write this equation like this. You just simply multiply 2 on the other side, so that will be equals to 2s is equals to vf plus v plus u into t, right? So it's up to you that how you are going to write this equation, and basically this is your second equation of motion. And second equation of motion, in second equation of motion, basically there is no quantity of acceleration, right? In first equation we are not having quantity of distance, and in second equation we are having time, initial velocity, final velocity, distance, but there is no value of acceleration, right? And if we want to relate acceleration with the distance, so we need to drive another equation, right?
Right. So there's only two equations?
No, there is one more equation. Basically there are three equations for motions, right? Because
Yeah.
initially in IGCSE level we only studied about Newton's second law and formula of acceleration, but this time we have to solve a motion with advanced application. So that's why we need to drive some advanced equations to solve your problem. So basically your third equation will be like this. S is equals to initial velocity into time plus half at square. So this is the third equation of motion that we need to drive. And for the derivative part, let's suppose if we again consider the graph, because this is a typical one to drive as compared to the previous two. So basically there are two shapes. One is the right angle triangle and second one is the rectangle one. So if we consider the rectangle part, so basically rectangle part shows you initial velocity with respect to time, because initially the body is at rest, right? If we consider the rectangular part, so that will give you the concept of u multiplied by t. Okay, why? Because we know that s is equals to uh, velocity multiplied by time. So basically if we need to find out the distance, so this area under the curve, this rectangular part shows you the concept of displacement, or you can also write it as initial velocity multiplied by time, because we know that final velocity is at different from point from this condition. So that's why if we want to find out the displacement, so we need to use the value of initial velocity multiplied by time. Okay. And for the second part, that is the triangle one. So basically that is the half of the rectangle, right? So that is the half area that is covered as compared to the rectangle. So first of all, if we write the first equation, so the first equation we derive is equals to, this is the first equation we derive, and the second one is, this is the second equation, right? Now what we need to do, from the equation we know that there is a concept of S equals to V plus U divided by 2 in second equation, right? So, and you also observe in equation number one that in equation number one, there is a value of V, right? So what if we just plug in the value of V in equation number two? So your complete equation will be with respect to the initial velocity, right? Because we know that in third equation, we need to drive with the reference of initial velocity, right? There is no concept of final velocity. So what we need to do, simple mathematical concept, we just substitute the first equation into equation number two. So if we do that, so basically we are going to use equation one in equation number two. So your new equation will be S equals to, in the place of V, we are going to write U plus AT, right? So this will be your new equation. And this is the value we just substitute from equation number one in the place of V. Okay. And if we just add all the values, so you will get equation S equals to, right? And finally, if we multiply T with the individual values, so you will get S equals to 2 times UT plus AT square divided by 2. And if we just divide or if we split the denominator like 2, we just divide 2 individually by 2 UT and then individually divide with AT square. So your equation will be, right? And finally, you
Yeah.
got your desired equation, because we can easily cancel out this two, and we simply write number as individual.
Hmm. And then can you like take the T as like common?
Yes, you can also take the T as a common, but actually I'm just driving with the equation that is written at the start of the derivative part. It's up to you that how you are going to arrange your equation, because in numerical, we know that we can arrange equation according to our situation.
Okay.
Because T is already common, right? We just multiply T with the other components, right? Initially, we know that both are common. Okay.
Okay.
And basically, there is one more equation that is for you. This one is We can say that this is just for a distance, right? Because s equals to vt, but we only take the average velocity, right? So we can say
Yep.
that you can write this equation as distance equation. So this will be, because you know that distance formula is the old one and that equation shows you the same concept. And the third equation is related to the concept like this. 2as equals to final velocity square minus initial velocity square, right? So we need to drive this equation. Now what we need to do, initially we just substitute the value of t from equation 1 in equation number 2. Now we again take equation number 1 and equation number 2, but this time we are going to substitute the value of t from equation 1 in your equation number 2. Okay, so your equation will be different this time. So we are again taking equation number 1 and equation number 2, but this time what we need to do,
So we have to because we okay, so we're gonna do 2.
yes, your for t, if we just simply write it, substitute the value of t from equation 1 in equation number 2. So basically, if we take the value from equation 1, so your t will
So
be equals to, yes,
it's
again the same concept, v minus u divided by a, right?
yep.
So this is derived from first equation. Now you can see that in equation number 2, t is in second equation, and we just replace the value of t in second equation. So your new equation number 2 will be like s equals to v plus u divided by 2. Now the value of t,
V minus U over A.
v minus u over a. And from mathematical formula, if you remember that formula, that a plus b and a minus b will be equals to a square minus b square. I will give the reference of that formula if you don't know about that. So basically your formula is, if we are having a difference of the square of two quantities, that is a square minus b square, let's suppose, so that will be equals to a plus b, a minus b, right? So this is the reference of the formula. And from this formula, you can easily understand that, let's suppose we are having variable v and u. So if we write v square minus u square, so that will be equals to v plus u and v minus u. Okay. If we just
Okay.
replace the variables, so let's suppose this is v and this is u, right? Because by doing multiplication, if you just simply multiply individually like this, first we need to multiply v from this value. Also we need to multiply v from this value, right? Because we have two quantities in both bracket, so there will be four values after multiplying each quantity with the quantity in the other bracket, right? So for the simplicity, we what we do, we just take the reference of the formula that will give you the same thing, right? I will also write the second method if you find second method easy. So you may do like that. Otherwise, you just use the reference of formula that a square minus b square will be equals to a plus b into a minus b, right?
Okay.
So your equation number 2 will be equals to S equals to V square minus U square, because we know the other two brackets will be converted into single one, divided by 2A. And we just simply multiply 2A on the other side. So basically this is our fourth equation and the third equation of motion. And we can also do or we can also drive the second equation with the alternative method. And what will be the alternative method? Let's suppose if we follow the next new method. So let's suppose we are not going to apply the formula, right? If you find that one difficult, so you can just take equation 2. So the initial part remains the same, the substitution of value of t. Now what we need to do, we need to multiply each and every variable. Like first we need to multiply v from both components, and then we need to multiply u with both components, right? So your equation will be like this: s equals to, sorry, this is a, right? And now if we just multiply the quantities, so your quantities will be, first we multiply v with v. So v into v is equals to v square. Then we are having minus sign. V multiplied by u will be equals to vu. Then we need to multiply this u with v, right? And finally, we need to multiply u with u. So plus minus minus u square. Okay. Any confusion?
No.
Okay. Now you can see that uv is in positive, also in negative. So you can just simply subtract that. You will get the same equation by using the formula method, right? And finally,
Yep.
you drive the same equation. So basically, it's up to you that you are going to perform the calculation or just you just write with the reference of the formula. Both will give you the same concept.
Okay. Got it.
So this is the equation from alternative method. Okay.